Hello and good afternoon, CSI257 students for the fall 2014 semester at Anne Arundel Community College for the third of 4 courses that are part of the Cisco Networking Academy, Scaling Networks. And today's PacketTracer tutorial will be on PacketTracer Activity 2.3.1.5, where we're going to configure some VLANs. We're going to take a look at spanning tree configuration, and we're going to talk about portfast and BPDU guard, or Bridge Protocol Data Unit guard. All right, so here we have our addressing table with our background information, and so it's going to ask us to step right in and start configuring VLANs. But before we do that, one of the things that students typically ask about, and what seems to be very confusing for a lot of students when dealing with spanning tree, has to do with the little plus sign that is right there. And so oftentimes you'll see PVST plus in documentation or on blogs, and on the switch you'll simply see it listed as PVST, right? And so if we come down here to, move my pin there, and this is a real Cisco 3750 switch, and so if I were to type show spanning tree, you can see here it's giving me the spanning tree information for VLAN 1, and I believe that this is probably the only VLAN configured on the switch right now. And you'll notice here that it says Rapid Spanning Tree Protocol, right, or RSTP. The spanning tree enabled protocol is RSTP. So if I were to change that, I could simply type in spanning tree mode, and if I put a question mark, you'll see that there are 3 modes that you can choose from. And the first mode, where's my pin at here? The first mode is multiple spanning tree, which is very popular. You've got per VLAN spanning tree mode, and then you have rapid per VLAN spanning tree mode. And so a little higher up, we had the rapid per VLAN spanning tree selected, and so you'll notice that there are no plus signs here, that they're missing. So let me go ahead and enable per VLAN spanning tree. So I'll say PVST, and then we'll run that command again to do the do show spanning tree. And as you can see, let me clear, get this out of the way here. All right, so you can see here where the spanning tree, which is enabled now, the protocol is IEEE. And so again, this is something that's very confusing to a lot of students. So they see IEEE or they see RSTP, but in a lot of the writings you end up seeing PVST plus, or you'll see rapid per VLAN spanning tree plus. All right, and so what the plus sign means is it simply means that the protocol will function over 802.1q trunks, right? And so to give you a little history, to go back, and we'll step over here real quick. So to go back to the different protocols that are out there, so we'll put P for protocol. So we had common spanning tree, and that came out right around, boy, I would say the 90s, right? The late 90s at some point. I would say 1998, where you had a common spanning tree, right? And that was known as 802.1d, okay? And the thing with the common spanning tree protocol is that the common spanning tree protocol only supported a single VLAN, right? So everybody had to be in the same VLAN to use the common spanning tree. So the IEEE as well as Cisco were both working on alternatives to the common spanning tree. And so what happened was you had the 802.1q, and I'll do per VLAN spanning tree. So you had 802.1q come out, and 802.1q, as you well know, is the open standard for the trunking protocol, but it also supported multiple VLANs across a trunk link, right? So that's where you ended up with the per VLAN spanning tree. Now, at the time, Cisco didn't use 802.1q. Cisco was using what was known as ISL, right? Inter-switch link. And so they were using per VLAN spanning tree, and they were using it with ISL, but the difference in the frame headers between 802.1q and ISL caused some problems. And so specifically, right, there is a BPDU bit flag with 802 with ISL that the IEEE decided against using. So when 802.1q came out, it did not support that BPDU bit. So you needed to have a unique bridge ID for every instance of spanning tree that you were running. And so the plus sign, Cisco basically changed their per VLAN spanning tree, and to make it compatible with 802.1q, they simply added the plus sign, right? So if you're running per VLAN spanning tree, PVST, oops, dropped out on me there. So if you're running PVST over an ISL trunk, right, and you should not, maybe in legacy environments, ISL has been deprecated, it's no longer supported. It does still show up on the code that I have on my 3750s, and I'll show you that in a second. So if you're running over ISL trunks, you're running per VLAN spanning tree. If you're running over .1q trunks, you are running per VLAN spanning tree plus on the Cisco side of the house, right? And the same is true for the rapid spanning tree, right? Or the per VLAN rapid spanning tree. So, don't want to change colors here. So the same thing stands. So the rapid spanning tree protocol, right? Or the per VLAN rapid spanning tree plus, right? So if it's got that plus there, it means that it's running over an 802.1q trunk. And that's really all the plus sign means. So now the next interesting fact is this IEEE. You'll remember that we put in here PVST, right? So when spanning tree was created, it was created by Radia Perlman, and she was working at DEC, Digital Equipment Corporation, back in the day. And so DEC submitted to the IEEE the spanning tree protocol and all the work that had been done by Radia Perlman, and the IEEE made a couple of tweaks to it, and then they went ahead and put out the standard for spanning tree. And so that's why you see spanning tree enabled protocol is the IEEE, right? Because it's the per VLAN spanning tree, okay? And that's why it doesn't say spanning tree enabled protocol DEC, right? So this just shows it's compatible with the IEEE, right? And it's per VLAN spanning tree. And if it's going over an 802.1q trunk, which nowadays it should, what you're really running, and you're on a Cisco switch, is per VLAN spanning tree plus, right? Or PVST plus. Okay, so hopefully that clears up any confusion on the plus sign and what that means. We've got it, did a brief history over here. There's also another version of spanning tree called MST, right? Which stands for Multiple Spanning Tree Protocol, and that's 802.1s, right? Looks like a 5, but it's an S. All right, so that's sort of a short history of spanning tree and the spanning tree protocol, and we're going to see some more examples here as we walk through the exercise. So let's go ahead and jump in to 2.3.1.5, PacketTracer 2.3.1.5, and we'll get everything set up here. So we'll configure VLANs step 1. So enable the user ports on switch 1, 2, and 3 for access mode, right? So it wants to put all of those in the access mode, and having read down further earlier, it's going to ask us to put spanning tree port fast and BPDU guard on those access ports. So here are the access ports and the VLANs that they should be assigned to. So let's jump right in here with switch 1. So on switch 1, I'm going to go from user exec mode into privilege exec, and then into global config. And we're going to go ahead and we're looking for FA0/6. And so what I'm going to do here is I'm going to say switchport mode access, because we're going to make it an access port. Switchport access VLAN, and this is going to be part of VLAN 30. And so you'll notice it says the access VLAN does not exist creating the VLAN. So it automatically created the VLAN for us. So now I'm going to go ahead and I'm going to type in spanning tree port fast, and we're going to get a message here. And this is important. It says port fast should only be enabled on ports connected to a single host. Connecting hubs, concentrators, switches, and bridges could cause bridging loops. And chances are that you stand a very good chance if someone's plugging switches into your switching environment that it will probably cause either a broadcast storm or a switching loop of some kind. So, but on access ports, spanning tree port fast is a very good feature to have turned on, especially host-facing access ports, for two reasons. The first reason is that the port doesn't go through all of the normal spanning tree states, right? The listening, the learning, and coming up, it transitions almost immediately into the forwarding state. And so that's a good thing. But that's not the best reason to turn on spanning tree port fast. The best reason to turn spanning tree port fast on has to do, and we're going to flip the page here, with what's called a TCN, or a topology change notification. And this gets sent out when changes occur on the network. And so if you have a switch, and so we'll draw a switch here, and you've got ports on your switch, and you don't have port fast turned on, and someone has a PC and they plug that PC in with an Ethernet cable, and port fast isn't on, and the switch port is up and operational, what will happen is this is going to force the generation of a topology change notification BPDU, right? I'll say BPDU. Or topology change bit will be set inside of the bridge protocol data unit. It will be flooded out from the switch where the activity is occurring, and it gets sent to the root bridge. The root bridge in your environment will then flood this topology change notification BPDU out to the rest of the environment. And so two things are going to happen. If you are running PVST, right, or PVST plus, PVST or PVST plus, we're going to say those are equivalent. If you're running those, what will happen is you've got about 20 seconds until the MAC table will flush, right? So it'll flush the entries that are in the MAC table and relearn all of the MAC entries in that VLAN on which that topology change notification BPDU is sent out. Now, if you're running rapid per VLAN spanning tree, right, what's going to happen is it's going to be immediate. Right? So immediately your CAM table, the MAC table, is going to flush, right? Now, normally this isn't a big deal, but I have seen this in multiple customer environments, especially environments where you've got different vendors participating in the network spanning tree setup. And I've seen it in pure Cisco environments as well, where someone takes their PC, right? And it gets plugged in and the port gets activated. Spanning tree port fast is not on. It's going to generate that topology change notification, and it's going to flood throughout the spanning tree environment, and it's going to impact all of the switches where that VLAN is present, where you plugged in, and it's going to flush the CAM tables. And so some hosts, some applications don't like that. And I've seen one customer with some access points where they had Aruba access points that didn't behave properly when this was going on. And so by turning on spanning tree port fast, it solved that issue. All right? And so that's very important to note, because a lot of people think that the primary benefit of port fast is, hey, I don't have to sit around and wait for 50 seconds for the port to become active. It becomes active immediately. However, the true benefit of port fast is really it suppresses that topology change notification from occurring, right? And so that's why you want it on, especially on host-facing ports where things are being plugged in, things are being unplugged, right? So it's a great idea to have that on. Okay, so we just turned on port fast, and now we're also going to turn on BPDU guard. So spanning tree, BPDU guard, and we're going to enable BPDU guard. And from the reading in this chapter, you'll remember that BPDU guard is there to protect us, especially on host or access facing ports where we're plugging in servers or PCs or access points or whatever the case may be. You don't want someone to be able to walk into your environment and then plug a switch into a port and start generating BPDUs, right? So BPDU guard, what it will do is it's going to move the interface into an air disabled state if it detects BPDUs. And the key here is that those BPDUs, right, if someone were to plug to come in, let's go back over to the drawing here. So if someone were to walk in and they've got a switch here, right, and we'll say this is switch 4, and they unplug F018 and they decide, hey, I'm going to plug this switch in here, and let's say that the bridge ID or the priority on this switch is 0, right? And you want this switch to be your root bridge, okay? What's going to happen is if this switch gets plugged in, if the priority up here is 4096, this switch will preempt that switch from being the root, and this switch will take over as the root, and this switch will no longer be the root. And that might not be what you want, right? So it's always a good idea to put BPDU guard on to make sure that if someone plugs a switch in, that it immediately air disables that port. Okay, so let's clear our screen off here. Let's go back to switch 1. Whoops, let's pull switch 1 back up. All right, so we've got BPDU guard on as well on switch 1. So I'm going to take a quick peek here. So we have to create some VLANs, and you remember it created that VLAN for us automatically. So we have to create 10 through 99, and this is, again, I think PacketTracer is a fantastic tool, but one of the shortcomings, and I'll show you right here. So if I exit down one level to global config and I type in VLAN 10, 20, 30, and I'll stop here because I know that it doesn't work. So if I wanted to put multiple VLANs in, I should be able to type in 10, 20, 30, and then I would hit enter and it would create those VLANs for me. And so PacketTracer doesn't support that. If I come down here to my 3750 and I type in, go from privilege exec to global config, and I type in VLAN 10, 20, 30, 40, 50, and so forth, right? I'll say 609. So if I type that in there, you can see if I do a do show VLAN brief, and let's look for 609 and 70, right? You can see that they don't show up in here yet, right? And if I type exit, right, if I exit from the VLAN configuration mode and then type do show VLAN brief and hit enter, you can see that now it does exist. And so that's something to be aware of, right? So I typed in the command, I added all those VLANs in, but I was still in VLAN configuration mode, so they did not show up. And also, notice that I could create all of those VLANs simultaneously, right? And so with the real Cisco IOS, you have much more flexibility than you do in PacketTracer. PacketTracer was going to force us to create them one at a time, so I've got a quick notepad document here to circumvent that. And I'm going to go ahead and drop that in right here, and you can see that's a great way to create all of those VLANs rather quickly. So if I do a do show VLAN brief, right, you can see in PacketTracer, they're automatically created, and I haven't exited out yet. So that's another difference, right? So remember that when you're dealing with the real Cisco IOS, and here I'll even drop over to switch number 2, and we'll run this again. So if I do a show VLAN brief, let's see which VLANs we've got here. You can see I've got 8, 22, 43, 58, and 100. So I'll just do 10, 20, 30, 40. So we'll go to global config mode, VLAN 10, 20, 30, 40, hit enter, do a do show VLAN brief, and they're not there, right? So in the real world, with the real Cisco IOS, you want to make sure that you're aware of that if you create the VLANs, and as you can see here, I'm still in VLAN config mode, I have to exit out of VLAN config mode for those VLAN creations to actually take place. And so now I'll do a do show VLAN brief, and you can see 10, 20, and 30. Let me make sure that was the command that I ran. Yeah, 10, 20, 30, and 40, and there they are. So there's 10, 20, 30, and 40. So PacketTracer kind of gives you the false sense of security that as soon as you run the command, those VLANs show up. However, in the real world, on a real switch, that's not the case. So please be aware of that. Again, like to cover the caveats because a lot of students become confused when we move from PacketTracer to the actual racks in the classroom where the behavior that they see does not mirror what you're seeing with PacketTracer. And so that's why I like to point these things out. Okay, so that's switch 1. We've got our access port created on FA06 and our VLAN. So I'm going to go ahead and, well, didn't necessarily need to log out there, but we'll, or I shouldn't say log out, but exit all the way out to privilege exec mode. So here we go, from user exec to privilege exec into global config. And so now we're going to do the same thing on switch 2. So let's do the VLANs first, right? So there we go. And again, do show VLAN brief. They're already there, right? But remember, that will not be the case with the real Cisco IOS. Okay. And so now we're going to go into interface FA018. And I didn't do the no shut over on, I typically like to do that right away. I'll get back over to switch 1 in a second. All right, so here we go. So we're in FA0/18 on switch 2. So we're going to do switchport mode access, switchport access VLAN 20. And we're also going to turn on spanning tree port fast. And we're going to turn on spanning tree BPDU guard with the enable command. And so then I already did the no shut command, so we should be good to go. So it's been configured as an access port. It's got port fast on, it's in the proper VLAN, and it has BPDU guard on as well. All right, so I'm going to type in and then write mem. So we'll save our config, and let me jump back so I don't forget here. So we'll go from privilege exec into global config FA0/6 and no shut. There we go. So do write mem. So we'll save that off. All right, so let's jump over to switch 3. And on switch 3, we're going to do the same thing from user exec into global config. I'm sorry, into privileged exec and now into global config. And we're going to knock all these VLANs out here. And again, if I do a do show VLAN brief to make sure that it's not an anomaly, it certainly isn't. PacketTracer is showing us those VLANs prior to their actual creation, right? So they're there, and then now we're going to go into in FA011. We're going to do no shut right out of the gate. So we'll do switchport mode access, switchport access VLAN 10 for this guy, and we'll do spanning tree port fast, and we're going to do spanning tree BPDU guard. Oops, BPDU guard enable, right? So if I do a do show run, and we come down to interface 11, you can see switchport access VLAN 10, switchport mode access, spanning tree port fast, and spanning tree BPDU guard enable, right? All right. So we've got the first 2 tasks knocked out. They've been created on all switches. So assign VLANs to switch ports. We've done that, right? So port assignments are listed in the table at the beginning of the activity. So here's our assignments. We've taken care of that. So step 3 is done. So step 4 says verify the VLANs. So use the show VLAN brief command on all switches And we did that. So if I do show VLAN brief, you can see they're there, and we saw those on switch 2 and 1 as well. So now we're going to assign the trunks to the native VLAN 99. So it says use the appropriate command to configure ports FA01 to 04 on each switch as trunk ports and assign these trunk ports to native VLAN 99. So configure the management interface on all 3 switches with an address. Verify that they're correctly configured by pinging between them. And so there, here at the top, there is our management information for VLAN 99. So we'll leave that up and visible here, and let's start out on switch 1. So back to switch 1, we're going to go ahead and do an int range, right? So that's interface range, FA0/1 to 4, right? Because we want to hit all 4 of those ports. So we'll do no shut right out of the gate to make sure that those are all up and operational. And it wants us to configure those as a trunk. So I would do switchport mode. If I do a question mark, you can see we can do trunk, right? And the interface state is going to change. So we've made all of those interfaces on switch 1 trunks, and switchport trunk native VLAN. And if I do a question mark, you can pick any of the VLANs from 1 to 1005, but here we're going to pick 99. Now, when I hit enter, chances are either on switch 1 or on the other switches, depending on how long it takes to get to them, we're going to see a message, or we should see a message here that pops up that says that there is a native VLAN mismatch between the trunk links. And so what I want to cover real quickly is, you'll notice that when we talked about the per VLAN, and there it is right there. So, and this is a very common error that you'll see in environments where people have just added switches and added switches and added switches, and they're trunking between them, and they really haven't done any due diligence in setting up those trunk links, right? By what you should really have is a VLAN that is not used for anything else. Typically in environments that I work in, I love to use VLAN 888, right, as the native VLAN. And I will use that throughout the environment, throughout the network or the enterprise, as the native VLAN. Okay, so we're seeing these native VLAN mismatch errors, and that basically just says that the native VLAN that I configured here, right, 99, does not match up with the native VLAN over on switch 3's fast Ethernet interface, right? 01, 02, 03, and 04, and it shows you what their native VLAN is. So by default, the native VLAN is VLAN 1. And so it's always a good idea to change and to use something else, right? And so again, in this lab example, we're using 99. However, you could change it to 888, you could change it to 999, right? And it's a good idea to do that. It's a good best practice to make that happen. All right, so something else I want to cover here is we talked about the PVST and the plus sign, right? That if the trunk is using ISL, right, then we are talking about just per VLAN spanning tree, right, or rapid spanning tree. And so the difference with the 802.1q is that then you would be using per VLAN spanning tree plus or rapid per VLAN spanning tree plus. Now with PacketTracer, if I were to do switchport trunk, and you should be able to do encapsulation, right? And you'll notice that there's no option here, right, for encapsulation. Now we can do switchport trunk allowed or native, so you can set the allowed VLANs, right, that are allowed to come across the trunk, or you can set the native VLAN. However, one critical factor is to be able to force it to use 802.1q, right, especially if it's an older switch. And so I have a 3550, which is definitely an old switch. And if I do a show, what do I want to do here? Show spanning tree. If I do a show spanning tree, you'll see that it's using, it says protocol IEEE, which is per VLAN spanning tree, right? And depending on what my trunks look like. So show interface trunk, and that's exactly what I was hoping to see. So again, on older switches, right, and you may run into this in legacy environments, the N simply stands for negotiating, right, which is due to the mode, the default mode on this trunk. And this is kind of outside of the scope of what we're talking about. The key here is ISL, right? So you can see that ISL is being used for the trunking mode. And so if I wanted to change the encapsulation, right, or the mode that the trunk is running in, I could do interface range FA0/13 to, we'll do 21, I guess we'll do them all. I should be able to type in Switchport trunk encapsulation, and if I do a question mark, you'll see you have choices here for .1Q or ISL. Now remember, ISL is deprecated and it's going away. However, depending upon the version of code that you're running, as well as the platform that you're working with in terms of the physical switches in your lab racks, you may run into this where you see ISL and .1Q. And so I want to make sure that you're aware of that, because a lot of students, if you don't see that here in PacketTracer, you're not aware that it actually exists. And so this is how you would force, that's how I would force the trunks to use .1Q. So now, if I do show spanning tree, right, you can see we're still IEEE, right? So that's not going to change. You're never going to see where it says spanning tree enable protocol. You're never going to see it say PVST plus or RPVST plus, or I'm sorry, PVRST. I got this back. It's PVRST. Sorry about that. Too many spanning trees. So PVR. Whoa, trying to draw with the mouse. PVRST. All right. So it'll never say PVRST plus or PVST plus. You're not going to see that, right? So, and if I do now the do show interface trunk, you'll see that the encapsulation is now 802.1Q. Okay, and so this is very important, right? Very important. Okay, so back over to PacketTracer where we have a native VLAN mismatch. We've just configured that range of ports to be trunks, and we also configured the native VLAN to 99. So let's go ahead and go over here to switch number, oops, we'll come over to switch 2. And as you can see, on the side where we've set the native VLAN, we're getting mismatch errors. However, on the side where the native VLAN has not been changed, right, we're seeing block PVID local, so blocking Ethernet 03 and 04 on VLAN 01, inconsistent local VLAN, right? And so it says receive BPDU with inconsistent peer VLAN ID 99 on fast Ethernet 04 VLAN 1. Because again, BPDUs are being sent from switch 1 over to switch 2, as well as switch 3, announcing, hey, this is my native VLAN, and I'm a trunk. And actually, I want to make sure that we look at that here. So if I do the do show interface trunk here, right, this is really the only way to see, or one of the ways to see, that you're using 802.1Q, right? So you can see we're using 802.1Q. So if I type in do show span for spanning tree, do show spanning tree, the spanning tree mode is RSTP, but we know that's PVRST, right? So per VLAN rapid spanning tree plus, because we're using 802.1Q. And so let me come over to switch 2 here, and let's go ahead and clean this up so these errors stop. So we'll go into global config mode, and we're going to do interface range FA0/1 to 4, and I'm going to say switchport mode trunk, and interfaces came up. Let's make sure. I'd just love to do no shut just in case. And then switchport trunk native VLAN is going to be 99. So as soon as we do this, it's going to solve the issue of the blocking. And you'll notice as soon as I type that in, we now get that the unblocked consistent port. So the consistency has been restored, right? So it's unblocking Ethernet 03 and 04, which are these two ports right here, right? Because we've now got the right VLAN for the native VLAN on there. So we'll do a do write mem. Come over to switch 3, right? We would expect to see the same errors, and we are. So I'll do an interface range FA0/1 to FA0/4, switch port mode trunk. Put the no shut in there just to be sure, and then switch port trunk native VLAN 99. All right, so we get the consistency errors are now gone. The inconsistency errors are gone, and we have port consistency. So we'll save our configuration here just to be sure. All right, so we've got the appropriate commands have been run. We are good to go on FA01 through 04. Now we're going to configure the management interfaces on all three switches, right? So we'll go back to switch 1 really quick, and we're going to type in int VLAN 99. I always do no shut, even though it tells me it's up. It's a habit. I like to be in that habit to make sure those interfaces come up. So IP address for this guy is going to be 172.31.99.1 with a subnet mask of, and you should have this down by now. This is the third course. So /24, right? So we have a class B address that's being subnetted with a class C mask. All right, and so we'll get that in there, and we'll go over here to switch number 2. We'll go int VLAN, int VLAN 99, and no shut, and IP address 172.31.99.2, and again /24, and then over to switch 3, int VLAN 99, no shut, and again the no shut. The VLAN is coming up. I just type no shut because I like do it out of habit so I don't forget. No shut, and we'll do IP address 172.31.99.3, and again /24, 255.0. All right, so if I do a do ping over to 172.31.99.1, it should ARP out, right? And then we should have success. There we go. So now if I do it again, it works. What if I do over to switch 2? Again, it's going to ARP out, try to get that information, the address resolution protocol information, and then it's good. Now we have an entry in the MAC table, so it knows how to get there. All right, so we're good on switch 3. Let's check switch 1. We'll do a do ping 172.31.99.2, and again, same thing. It's going to have to ARP out, and then it's going to work, right? It's perfect. And we'll check switch 3, and that should work automatically because switch 3 already pinged switch 1. And then we'll check switch 2. So do ping 172.31.99.1, and it should work automatically, or it should work right away with straight away with both .3 and .1. Okay, so we're good. So we've verified that we've got management VLAN connectivity. All right, now here's where we're going to get into the challenging part here, right, is configuring spanning tree per VLAN spanning tree plus, okay, and we're going to be configuring load balancing. So the root switch is responsible for generating BPDUs for spanning tree protocol 802.1d and is the focal point for spanning tree to control traffic. The root switch must be capable of handling the load, and switches today that's pretty much a non-factor today in terms of load with handling the root function of spanning tree. So we're going to configure the spanning tree mode, right? So we'll start on switch 1, and the mode is going to be set to PVST. So if I do a do show spanning tree, we'll scroll up, you can see right now it's the rapid spanning tree protocol, right? And so if I do spanning tree, oops, let me jump back one level here. If I do spanning tree mode and a question mark, you can see, so that rapid spanning tree mode, right? That per VLAN, PVRST, I got to keep that straight, PVRST, that per VLAN rapid spanning tree is what we're currently using. And this is asking us to change the mode to PVST. So I would type in PVST, and that's per VLAN spanning tree mode. Okay? So I've just changed the mode of the spanning tree. So if I do a do show span, and we come back up, you can see that it's now changed. It says spanning tree enabled protocol IEEE. So it simply means that it's using the per VLAN spanning tree, right? That's compatible with the IEEE's protocol for per VLAN spanning tree. But we know from a Cisco perspective, do show int trunk, that since we're running 802.1q, we're really running what Cisco refers to as PVST+. And you can see here, again, in the documentation, that's how they refer to it. And that's typically, like I said, they don't do it here, right? Because the protocol is not PVST+, right? We're flipping it to PVST. But in a lot of the documentation from Cisco, you'll see PVST+. And if you do a Google or a search on, you know, PVST versus PVST+, there are a lot of great posts out there that talk about the differences. And the same thing with the PVRST+ and the PVRST. So, but again, that plus, that's sort of Cisco's way to confuse everybody, I guess. But again, it's not really for confusion. It's simply to differentiate that that's their sort of flavor of per VLAN spanning tree that's compatible with the 802.1q standard, right? Okay, so we've got switch 1 set up and we flip the mode. So let's flip the mode on switch 2. So I'll come over here to switch 2 and we're going to say spanning tree mode PVST. Right, and then finally we'll come over to switch 3 and we're going to say spanning tree mode PVST. All right, so we've flipped the mode to PVST on all 3 switches. Now we're going to configure spanning tree PVST plus load balancing. Okay, so switch 1 is going to be the primary route for VLANs 1, 10, 30, 50, and 70, and switch 3 is going to be the primary route for VLANs 20, 40, 60, 80, and 99. Okay, and so there's 2 ways that we can do this, and there's some very subtle differences here that you should pay close attention to. So we're going to go ahead and say spanning tree and VLAN, and actually you can do a range here, which is nice. So I'll say we're on switch 3, so we're looking at 20. And no spaces in there. 20, 40, 60, and 80. Is that right? All right, 20, 40, 60, and 80. And we can type in the priority, right? So we can set the priority of those VLANs on this switch, right? Starting at 0 and working up to 49, or I'm sorry, in increments of 4096 up to 61,440, right? So we could set this switch to be the root, and lower is better, right? So if I put 0 in here, the only way that this switch would lose out being the root in an election is if another switch had a lower MAC address, right? Because 0 is the lowest value. So I could put 0 in here, right? And then that would set the priority of this switch for those VLANs to 0. And this would be the root bridge for those VLANs, okay? So that's one way to do it. And again, I could do 0, I could do 4096, I could do 16384, right? Whoops, 384. So as long as it's in increments of 4096, okay? Now, the priority is one way to do it. Another way to do it is to type in root and primary. Okay, so if I typed in spanning tree VLAN 20, 40, 60, 80, root primary, what this is going to do is this is going to take a look at the environment as it stands right now, and it's going to make this switch the root bridge, right, the primary root bridge for those VLANs. But what this command is actually doing, it's simply running a macro in the background, and it's looking at the bridge priorities that exist for these VLANs right now, and it's going to lower it by 4096. So, without executing that command, let's take a look at, and we're on switch 3, we'll pop over to switch 1 real quick. So on switch 1, if I do a do show spanning tree, right? And we'll take a look at, we'll say VLAN 10, or let's go to VLAN 20. That's one that's going to be changing here, right? Whoops. So here's VLAN 20. And here's our information for VLAN 20, and I'm gonna dare to get the pin out here. So some key things to notice here, right? So the root ID, okay, when you do that do show spanning tree, it's going to give me the MAC address of the root bridge. Now, the address of my switch, right, the bridge ID of this switch, of switch 1, here is the MAC address. So I am not the root bridge for VLAN 20, right? This switch with that MAC address, and we could go look at the other switches to see, that guy is going to be the root bridge. The other key field here is the priority. So by default, the priority is 32,768, right? So remember when I was going to set the priority, I said 0, or I could do it to 4096 or 16384. This is the default priority with spanning tree. It's 32,768. So the system ID extension, right, or the system ID extended, where it shows the VLAN number here, this gets added to the default priority, and that is how we end up with the true priority here of 32,788, right? So the default priority is 32,768. You add the VLAN number to the default priority, and that gives us the true priority here. So you can see that these two switches, for the two switches listed here, the root switch, and this is switch 1, right? This is my bridge ID, and you can see here, I'm on switch 1, right? So this is my bridge ID. For VLAN 20, this guy was selected as the root. And remember I said, if the bridge IDs are the same, right? The values are the same, and they are 32,768, 32,768. The tiebreaker, and let me clear the screen here real quick, I just wrote over it. The tiebreaker becomes the lowest MAC address. And so if you look, 003 is lower than 005. And so that is why for VLAN 20, this switch right here was selected as the root bridge. And in fact, if we scroll through, let me clear the screen out here and get rid of the pen. So if we scroll through, let me get the mouse in here real quick. All right, my mouse has disappeared. There we go. All right, we're back. All right, so if we scroll through, you're going to see that for VLAN 30, we are also not the root bridge. In fact, again, that low MAC address of 003 is going to win out every time. Whoops. Going to win out every time. Okay. So, again, we are not the root bridge for anything because our MAC address is higher than the MAC address of the switch that won out as the root. Okay. So let me see if I can get this back. Having some mouse issues here when I click in here. It's kind of dropping. The mouse is dropping out. All right, so it likes it with the pen, but not so much with the mouse. All right, so we'll work with the pen here until we wrap up. So that's switch 1. So I've made that change over on, if I'm not mistaken, did we start with switch 2? No, we started over here with switch 3. There we go. All right, so for switch 3, I'm going to go ahead and I'm going to hit enter. And remember, this is running a macro that is going to set the priority. So if I do a do show run at this point and hit enter, you can see that the spanning tree value, right, the priority got set, and it got set to 24567. And so in a default setup, right, this is what that macro will set the priority to. And so this is why these two methods are very important here, right? So if you use the macro and you run spanning tree VLAN 2040-6080 root primary, it's going to run a macro and it's going to drop it. Again, if everything is at the default of 32.768, it's going to drop it to 245.76. However, if you have another switch in your environment that is set to 4096 and is currently the root and it has these VLANs, this is not the number that you would end up seeing here, right? So if I were to try to run this command, and let's say, I don't know if I want to risk it with PacketTracer hanging up, but if I were to run this same command right here over on another switch and do the root primary, it should drop it to 20 or whatever 4096 minus this number is, right? So let me give that a try, because we're at 83 out of 100. So on switch 1, if I were to run that same command that we saw run, so spanning tree, and we're going to say VLAN 20, 40, 60, 80, right? And then we're going to say root primary, and I hit enter. I've now told everyone that I should be, all right, good, spanning trees, or I'm sorry, spanning tree, PacketTracer is cooperating. So you can see what happens here, right? So it simply runs a macro that goes out and looks and says, hey, what is the current priority for these VLANs in the environment, and drops it by 4096, because I just said, hey, I want switch 1 to be the root bridge for those VLANs. But if we go back over, let's go back over to switch 3 now and do a do show run. And you can see it's still in here. And so this is very misleading, right? Because you're thinking to yourself, hey, I ran that command saying root primary, and the macro ran and it dropped this value in here. But if I do a do show spanning tree, let's go down to VLAN 20, which is right here, right? You'll notice that here's my bridge ID, which is lower than that bridge ID right there. And we've seen this guy. That's switch 1, right? And you can see that it shows the priority, but again, that priority has 20 added to it, right? So the system ID extension, so this was 24576, has 20 added to it, so it's 24596. Over on switch 1, let's jump over to switch 1 real quick. You can see 2480, so 20,480 plus 20 is 20,500. And so that's where that value shows up. This is switch 1, right? And it is the root bridge. But if we didn't know any better, if we don't understand what that macro is doing and what those values mean, when we come back in here and look at our do show spanning tree, this is where confusion starts to come into play. All right, so we're going to go ahead and we're going to come back over here to switch 1. And I'm going to recall that command. I'm going to do Control A, and the Control A moves me to the start of the line. I'm going to say no. Spanning tree VLAN, root primary. For those VLANs, if I do a do show run, you can see that it's now gone. So let's make sure here. Let's drop back over to switch 3. Let's see what switch 3 says now. So if I rerun that command and we go to take a look at VLAN 20, you can see here it still has spanning tree protocol. It still sees switch 1 as the primary, right? And so let's give it a couple seconds and see if it's going to solve the issue on its own. No, it still sees switch 1 as the primary. Let's make sure that for those VLANs, let me recall that command up, and let's do spanning tree, and we're going to say VLAN. We'll do 20, 40, 60, and 80, and we're going to set this to a priority of 32.768. So we'll set it back to, for those VLANs, back to the defaults. If I do a do show span, and we'll take a look at 20, you can see, and this is kind of where I'm not a huge fan of PacketTracer, because it looks like it may have, it's got this locked in here as the root value. So, and it still sees me. Does it make sure it sees me as the root value? Yeah, so this bridge is not the root bridge. So it looks like, take a look at some of the other ones and let's see, 40. Yeah, so we've got 50, what about 60 and 80? So here's 80. So again, on switch 1, which is that MAC address right there, we are still showing up as the root bridge. So let me see if I can clear this out here. So if I do a do show run, I may have blown up my own example. So I'll do a end, we'll do write mem, save our config, and I'm going to reload. And it should be pretty quick. And sometimes this happens with PacketTracer, where you wouldn't necessarily see behavior like this. So we'll do a show span. Let's see what we see now for VLAN 20. All right, so it looks like that has solved the issue. Okay, good deal. When in doubt, reload, especially with PacketTracer. Okay, so again, we've got the default value here, right, 32768, and it's showing that 0030 has been elected as the root switch. And so let's rerun that over here. And I'm hoping that we don't have to do that on every single switch. And so as you can see, my bridge ID, right, my address is listed here. And so I am, if these match, right, typically you may see something here that says this is the root bridge, right? So, or this ID is the root bridge ID. So I am, my address matches for the root ID. I am the root ID. That's what we would expect. And so let me go ahead and not cause any additional problems here doing demos. And let's see, switch 1 is the next switch that we need to manipulate here. So on switch 1, I am going to say spanning tree VLAN, and we're looking at 1, 10, 30, 50, and 70. Is that right? And I don't think I did 99 on switch 3. I may have stopped short of 99. So we'll take a look at that real quick. And so again, I'm going to go ahead and I'm going to say root and primary. And I'm going to make this guy the primary for 1, 10, 30, 50, and 70. So I do a do show run. And as you can see, the output shows for spanning tree, right? There's my priority. And if I do a do show span, we should see right out of the gate that is VLAN 1 right there. And so the root bridge address, MAC address, is 0050, and it matches me, right? So we'll take a look at 10. We're good, right? So 10, it matches up. We'll come down here. What was another one we did? 30, 50, the odds, basically. So here's 50. All right, we're good. And again, this value here is the value that was set to 24576, I believe, and plus 50, right? Okay, so it looks good. Let's take a look at switch 3, make sure we get VLAN 99 included in there. And we did not have it in there, so let me run that one more time. I'll just put comma 99. All right, so if I do a do show span for do show spanning tree, and we're going to go all the way to the end, which is where we'd expect to see 99, and sure enough, right, and there's that value, that 24675 is basically, if you were to subtract 99 from that, it would give you do show run. It would give you 24576, because that is the priority that the macro has put in there, right? Again, if you don't want to let the macro make that decision for you, and typically in enterprise environments you do not, you want to make sure that you are hard coding in that value and not depending on the macro to kind of go out, look around, figure things out, because you may add switches in later, make modifications, but Again, the difference is this is running a macro, right? That spanning tree VLAN, blah, 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 root primary, and it produces this. The better idea is to run this command and say priority 0 or priority 4096 or priority 8192, right? Okay, so we're now at 89 out of 100 points, and I know we've got some additional work to do here. So let's take a look over on this side. So we've done that. So configure switch 2 to be the secondary route for all VLANs, right? So here's switch 2, and let's go ahead, and we haven't done much with switch 2, so we'll go from user exec to privilege exec into global config, and I am going to say spanning tree VLAN, and this is all VLAN, so 1, 10, 20, 30, 40, 50, 60, 70, 80, 99, and it wants us to make it the secondary, right? So we would say root question mark, and this is what it's calling for here. And again, watch what happens when I type secondary, and this is really a macro. Again, it's right. If I wanted it to be the secondary, I could simply take a look at the primary values, right? And then hard code this in with the priority command with the spanning tree VLAN 1, 10, 20, 30, 40, 50, 60, 70, 80, 99 priority, and then hard code the priority in. By doing it this way, watch what happens. So the macro is going to run, and if I do a do show run, you can see that what happened is it's now 28,672 for every single VLAN, right? And so remember, on the do show run here, the value we end up with is 24,576. So what's the difference between 28,672 and 24,576? The difference is 4096, right? So there's a difference of 4096. And that's how this command functions. And again, this will work, but I highly recommend that if you're going to be doing this, that you hard code those values to something you can control, right? So let's go ahead and wrap this activity up, and whoops, I'm going to bring those windows back. All right, we're going to go ahead and wrap our activity up here. So we've got that in there, the show spanning tree. So let's do that on switch 2. If I do a do show spanning tree, we should not be the primary for any of the VLANs, right? Because we just said we're the secondary. So you can see here 050, whoops, 050 for VLAN 1, that's switch 1. There's the MAC address for me, right? So this bridge ID information, remember, this is my bridge ID information, okay? So we'll go down, let's just randomly check. Nope, there's switch 1 again, and then there's my MAC address. So I'm not the root. And I'm looking for, there we go, 80. So this would be, 80 was set up on, if I'm not mistaken, switch 3? Yes. So here's switch 3's MAC address, and here's my MAC address. So again, as you can see, I'm secondary for everything, right? For every VLAN on switch 2. Okay, so we're good there. We've done our show spanning tree. So now configure port fast and BPDU guard. So this is what we've already done. So we're good to go there. And again, doesn't mention here, when it talks about port fast, it says that it puts the fort in the forwarding state almost immediately. It can dramatically decrease the time of listening and learning states. And this is true. It can. And again, but this is not, and let me get the pin up here, port fast minimizes the time it takes for the server or workstation to come online. It does, but that is not the primary benefit of port fast. Remember, the primary benefit of port fast is all about the topology change notification, right? BPDU. My pen skills are failing me this evening. All right, so it does skip that 50-second wait time, and it almost brings it online immediately, but it also suppresses that BPDU, which is a good thing, right? All right, so as you can see, we are 100 out of 100. And spanning tree is one of those topics. It is one of the most confusing topics that's out there because of so many different ways to represent things, right? The PVST plus, the PVRST plus. Why does it say IEEE at the top, right? So it's good to know a little bit about the history of those things in your studies. All right, so this wraps up PacketTracer Activity 2.3.1.5, and I definitely hope that you have found this to be a valuable tutorial. Please, you can go ahead and send me any inbox feedback, whether you liked the video or didn't like the video, and hopefully this helps you out. And please feel free to pass along the link to this page to anybody that you're studying with who may be struggling with spanning tree, and hopefully this will help them out. All right, enjoy the rest of your semester, and I'll be posting videos up on and off throughout the semester, and thank you for watching.